All right. So this is going to be the last part of our measuring the stars notes. And we found the distance a couple different ways to stars. So far we've done parallax. Unfortunately, that only works for a few nearby stars because the parallax angles are so small. And then we've used the difference between the absolute magnitude and the apparent magnitude, that m minus m, and use that to find the distance. We're going to use Cepheid variables to find the distance. We're still going to use the m minus m, but there's something special about these Cepheid variable stars that makes them very useful. So they are stars that are up to 100,000 times brighter than the sun. So they're really easy to see. And the other thing that's important, they're called variables because they change, they pulsate, which makes them get bigger and smaller, and then because they're getting bigger and smaller, they're getting brighter and dimmer. And their rate of pulsation, how fast they pulsate, depends on their mass, which in turn affects their brightness. And that's the absolute magnitude or the capital M thing. All right. So when we see a Cepheid variable, we can measure their apparent magnitude from Earth. So that's the little m. Then we measure their rate of pulsation and use it to find the absolute magnitude. The big M. And then we use that difference, m minus m, to find their distance. Now, it's important because they're so bright we can see them from very far away. So we can use parallax for only a few nearby stars. These things are so bright, we can measure their distance even if they're very, very far away. And it's the only way to directly determine the distances to other galaxies. So, how do we do it? Well, I'm going to give you data for a Cepheid variable. It looks something like this. And I'm going to give you that the apparent magnitude, the little m, is 2.2. I'll maybe make a note of that over here. Okay. And then we got to measure its period, which is the time it takes to make one cycle. So you pick a high point, pick another high point. That is going to be one cycle. So this is at 60, that one's at 40. So 60 minus 40 is 20 days. So the period for this thing is 20 days. So it gets bright, roughly 10 days later it's dim, and then 20 days from the start it gets bright again. And then we're just going to look this up on a chart, and we're going to find the period down here. So 20, we're going to go up to here, and then we're going to go across, and that's going to tell us the absolute magnitude. And there's -5 for that one. So the big M is going to be -5. So we have the little m here and the big M here. Now I'm just going to copy those over onto the next page. So the apparent magnitude, the little m, was 2.2. The big M was -5. Then we have to do little m minus big M. So 2.2 minus -5. And you can do it in your calculator, or remember, minus is a plus. So 2.2 plus 5 is 7.2. So my m minus m is 7.2. Then we're just use this chart, which we've used before, and to estimate the distance. So here's 5, there's 10. 7.2 would be somewhere in here. All right, 7.2. And we would go up and then go across. And it's somewhere between 100 and 500. So we might estimate that the distance is about 300 parsecs. The distance is about 300 parsecs.